In this video, we will be discussing a few questions of trigonometry, the proof type questions. And if you're not very clear with the formula in trigonometry, then I've left a link in the description box below where I have discussed only the formula of trigonometry. So do go through that video once and get thorough with the formula of trigonometry so that you can understand the contents of this video in a better way. For all those who are clear with the formula of trigonometry, let's begin with the questions. Now these questions I've taken them from the Maharashtra government textbook, Maths Part 1, 11th Standard, Exercise 3.3. Like I have said in my earlier videos also, you need not be a student from the state board only to understand all these questions. No matter whichever board you belong to, you will find these questions in some or the other corner of your textbook. So with that, let's begin with the first question. On the left hand side, you have 1 minus cos 2 theta divided by 1 plus cos 2 theta. There were three formulae for cos 2 theta, and in the numerator that cos 2 theta I will write it as 1 minus 2 sine square theta. The reason is when I open the bracket, this 1 minus 1, they cancel off each other and I am ultimately left with only one term in the numerator. In a similar way, because I have a plus here, I will write the denominators cos 2 theta as 2 cos square theta minus 1. Just open up the brackets. This becomes 1 minus 1 plus 2 sine square theta. This would simply remain as 1 plus 2 cos square theta minus 1. 1 minus 1 gets cancelled. 1 minus 1 gets cancelled. Then we are left with 2 sine square theta upon 2 cos square theta. 2 and 2 also get cancelled. And finally it is sine square theta upon cos square theta, which is equal to tan square theta. And that's what you have on the right hand side. In the later part of this video, there are these two formulae I am expecting you to remember. Or these are two things I am expecting you to remember as formula only. That 1 minus cos 2 theta by the simplification that we had just done here. That 1 minus cos 2 theta can be written as 2 sine square theta. And 1 plus cos 2 theta can be written as 2 cos square theta. Check carefully that if the angle here was 2 theta, the angle here was half of it, which is equal to theta. So with a minus, we had 2 sine square theta. If it is 1 plus cos 2 theta, we have a 2 cos square theta minus 2 sine square theta plus 2 cos square theta. Okay, here's the second one, and all we need to do on the left hand side is we just need to expand the brackets. So that would become sine 3x into sine x plus sine square x plus cos 3x into cos x minus cos square x. Now if I combine this and this together, the two terms here are of the type cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B is like cos of A minus B. So this becomes cos of 3x minus x plus we have sin square x minus cos square x. Let's write it as minus of cos square x minus sin square x. So the first term becomes cos 2x. If you realize, the second formula is basically the expansion for cos 2x. So cos 2x minus cos 2x becomes equal to 0, and that is what you precisely have on your right hand side. So that is how we are solving our second sum or proving that second sum. Go ahead with the third one. All you need to do is a plus b the whole square and a minus b the whole square expanded by the general formula. So the first term would be cos square x plus 2 cos x into cos y plus cos square y plus sin square x. This is the expansion of the second bracket now. Sin square x minus 2 sin x into sin y plus sin square y. Check carefully how we are clubbing the terms. Cos square x plus sin square x will be 1. Cos square y plus sin square y will also be equal to 1. So we are having a 1 plus 1. 2 cos x cos y minus 2 sin x sin y. That will give you plus 2, and in the bracket it will be cos x cos y minus sin x sin y, which is basically the expansion of cos x plus y. So now 1 plus 1 becomes equal to 2. 2 plus 2 times something. We can pull out a 2 common from the two terms and write the whole thing as 2 into 1 plus cos of x plus y. Remember, I had said this in the very first question. 1 plus cos 2 theta is 2 times cos square theta. Had it been a minus here, I would have said 2 sin square theta. This becomes 2 times 2 into cos square theta. But keep in mind, when I'm writing that cos square theta, the angle inside cos square is basically half of whatever comes here. So this would be x plus y the whole upon 2. And that is what you have on the right hand side, because this 2 into 2 gets multiplied, giving you 4 times cos square x plus y the whole upon 2. And that is your right hand side. So this is how we are proving the third question. Go ahead with the fourth one. It's exactly the same question. So if you expand this, you get cos square x plus cos square y minus 2 cos x into cos y, plus expanding this will give you sin square x plus sin square y minus 2 times sin x into sin y. So cos square x plus sin square x will be 1. Cos square y plus sin square y will also be 1. That 1 plus 1, let's directly write it as 2. Then minus 2 cos x cos y minus 2 sin x sin y. We are pulling out a minus 2 common. So that will leave us with minus 2. In the bracket it will be cos x cos y plus sin x sin y, which is basically the expansion of cos x minus y. Now, from the two terms here, you can pull out a 2 common. So when that 2 goes out common, we are ultimately left with 1 minus cos of x minus y. 1 minus cos theta, like I said, was 2 sin square theta. 1 minus cos 2 theta was 2 sin square theta. So the angle inside sin square will be half of whatever you have here. 2 into 2 gives you 4, which is what you precisely have on the right hand side. And that is how you are proving the fourth question. Go on with the fifth. This is a very simple one. All you need to do is write tan as sin upon cos, write cot as cos upon sin. So we have sin x upon cos x plus cos x upon sin x. When you just add up the two fractions by cross multiplying them in the numerators and multiplying the denominators to get the final denominator here, you have sin x cos x in the denominator. In the numerator it will be sin square x plus cos square x. But sin square x plus cos square x will be 1. And just to get our final answer, we are multiplying the numerator and denominator by 2. So in the numerator you are left with 2. In the denominator 2 sin x cos x is going to become sin 2x. That sin 2x goes in the numerator and becomes cosec 2x. So 2 times cosec 2x is what you have on the right hand side. And yes, that is how we are proving our fifth question. Let's go ahead with the sixth one. In the sixth one, okay, I'm not very sure about how will we proceed in this. Let's proceed in the general way. We will add the numbers like we are adding two fractions. Subtract the two numbers like we are subtracting fractions. So cross multiply in the numerator and multiply the denominators to get the final denominator. So in the numerator it will be cos x plus sin x the whole square minus cos x minus sin x the whole square divided by cos x minus sin x into cos x plus sin x. So in the numerator it is cos square x plus 2 sin x cos x plus sin square x minus, when you expand the other bracket you get cos square x minus, okay, I'll write that in a bracket, cos square x minus 2 sin x cos x plus sin square x. So that when you open the bracket, this will be minus cos square x plus 2 sin x cos x minus sin square x, the whole divided by a minus b into a plus b. So this will give you cos square x minus sin square x. Now cos square x minus cos square x goes off, sin square x minus sin square x gets cancelled, and we are left with 2 sin x cos x plus 2 sin x cos x, which is actually equal to 4 times sin x cos x. Let's write it as 2 times 2 sin x cos x. Cos square x minus sin square x is going to be cos 2x, and 2 sin x cos x is basically sin 2x. So sin 2x upon cos 2x, that gives you tan 2x. So this is 2 times tan 2x, which is what you have on the right hand side, and that is how you are proving the sixth question. Go ahead with the seventh one. You can write 2 plus 2 cos 8x somewhat in this manner. You can actually pull out a 2 common from here and write it as 1 plus cos 8x. But 1 plus cos 8x becomes 2 cos square 4x, and 2 into 2 will make it 4. So we have 4 cos square 4x. So that is what we have inside the square root here. This entire expression is basically 4 cos square 4x, and when you take a root of it, you get 2 cos 4x, and that is what we will now be writing. So we will write that entire root, the value of that entire root as 2 times cos 4x. So we have root over 2 plus root over 2 plus the value of that entire root just turned out to be 2 times cos 4x. We can proceed in a similar way now. This would be root over 2 plus, pulling out a 2 common from here would give us 2 times 1 plus cos 4x. 1 plus cos 4x would be 2 times cos square 2x. 2 into 2 would be 4, and root of 4 cos square 2x, that would be 2 cos 2x. Pull out a 2 common from here again, and we have 1 plus cos 2x. 1 plus cos 2x would be 2 cos square x. 4 cos square x, the root of it will be 2 cos x. And that's what you have on the right hand side. And yeah, that's how we are solving our 7th question. Let's go ahead with the 16th one. It's again a simple question because all you need to do is write that 16 as 8 into 2. Then consider 2 sine theta cos theta, which is equal to sine 2 theta. So we have 8 into sine 2 theta into cos 2 theta into cos 4 theta into cos 8 theta. So by now you might have understood what we are going to do. Consider this 8 also as 4 into 2. Then 2 times sine 2 theta cos 2 theta. That makes it sine 4 theta. You had a 4 here. Then consider that 4 again as 2 into 2. So then you can say that 2 sine 4 theta cos 4 theta. The 3 terms get combined, giving you sine 8 theta. And now you are left with 2 sine 8 theta into cos 8 theta. And the value for that entire expression would be sine of 16 theta. 2 sine 8 theta cos 8 theta, that is sine 16 theta, which is what you have on the right hand side, and that is how we are proving the 8th result. Let's go ahead with the 9th one. Just cross multiply the numbers to get the numerator and multiply the denominators to get the final denominator. So it is sine 3x into sine x plus cos 3x into cos x divided by cos x into sine x. Now cos a cos b plus sine a sine b, that's the expansion of cos a minus b, which is cos of 3x minus x. In the denominator, let's multiply that thing with 2. So we have 2 sine x cos x into 2. So we are finally left with 2 times cos 2x divided by the denominator is now equal to sine 2x. But then cos 2x upon sine 2x, that becomes cot 2x. And that is what is your right hand side. And yeah, that's precisely how we are solving the 9th question. Take the 10th one. We begin again with our left hand side, where they have said cos x upon 1 plus sin x. Now cos x, I will use the half angle formula. I know that cos 2 theta is cos square theta minus sin square theta. So while using this formula, the angle here is becoming half of whatever it was on the right hand side. So that means if I have cos x, I can write it as cos square x by 2 minus sin square x by 2. That's how I am writing the numerator, and check very carefully how I write the denominator. I can write sin x as 2 sin x by 2 cos x by 2. Okay, and at the beginning I have that 1. 1 will be written as sin square theta plus cos square theta, but the choice of theta will depend upon the terms that I have here. I will write that one as sin square x by 2 plus cos square x by 2. So the one which we had here, we are writing it as this one. We are writing it as sin square x by 2 plus cos square x by 2. Now when I do that, the left hand side finally becomes, in the numerator it is of the type a square minus b square. So we can write it as a plus b into a minus b. Keep in mind the angle which I have with cos and sin is x by 2. In the denominator it is a square plus b square plus 2ab. That means in the denominator what we have is a plus b the whole square, which is cos x by 2 plus sin x by 2 the whole square. Now from here on it's very easy, because cos x by 2 plus sin x by 2, one of it gets cancelled in the denominator and numerator. We are finally left with cos minus sin upon cos plus sin, the angle in each of them being x by 2. Divide the numerator and denominator with cos. So we get cos x by 2 minus sin x by 2 upon cos x by 2, divided by cos x by 2 plus sin x by 2 upon cos x by 2. Separate the terms in the numerator, it will be 1 minus sin x by 2 upon cos x by 2 would be tan x by 2, divided by this would also be 1 plus tan x by 2. The result that we just got is the expansion of tan 45 minus x. So this is tan 45 would be pi by 4. Okay, I am so sorry, I shouldn't have actually done these steps. Instead of dividing by cos, I should have divided with sin, because this is what we wanted, and to get a sin, to get a cot, it is more appropriate to divide with sin. So if I divide the numerator and denominator with sin x by 2, then on splitting I get the first term as cot x by 2, cos x by 2 upon sin x by 2, making it cot x by 2 minus 1, divided by, in the denominator I will similarly be having cot x by 2 plus 1, and that is what you have on your right hand side. Yeah, so that's how we are solving our 10th question. Let's move on with the 11th one. All the angles are theta by 2, so I'll just write S and C for sin theta by 2 and cos theta by 2. In the numerator it is tan theta by 2, that is sin by cos, plus cot theta by 2, which is cos upon sin. Similarly, the denominator is cos by sin minus sin by cos. If you combine the terms in the numerator, it is sin square plus cos square upon sin cos, divided by cos square minus sin square upon sin cos. Sin cos gets cancelled, the numerator term is 1. We have 1 upon cos square theta by 2 minus sin square theta by 2, and that would be equal to cos theta. So 1 upon cos theta becomes equal to sec theta, which is what you have on the right hand side, and yeah, that's how we are proving the 11th sum. On the left hand side, again we can write this as sin and cos, sin and cos. So when you write everything in terms of sin and cos, it is 1 upon sin 3a upon cos 3a minus sin a upon cos a, minus 1 upon cos 3a upon sin 3a minus cos a upon sin a. Just cross multiply the terms here, and that should be sin 3a cos a minus cos 3a sin a divided by cos 3a cos a. We have similar expressions here, cos 3a sin a minus sin 3a cos a divided by sin 3a sin a. Okay, let's take that cos 3a cos a in the numerator. And let's take this sin 3a sin a also in the numerator. Now sin a cos b minus cos a sin b, that is the expansion of sin a minus b. So we have the denominator as sin of 3a minus a, which is equal to sin 2a. So the denominator has become sin 2a. We can take this, we can take a minus sign common from here. So if I take a minus sign common from there, this becomes plus, and this becomes sin 3a cos a minus cos 3a sin a. Okay, now sin a cos b minus cos a sin b is again the expansion of sin a minus b. So this would be sin of 3a minus a, and that should be equal to sin 2a. Now because the denominators are the same, we can simply add up the terms in the numerator. So when you add up the terms in the numerator, cos 3a cos a plus sin 3a sin a, it is of the type cos a cos b plus sin a sin b, and that becomes cos of a minus b, that is cos of 3a minus a divided by sin 2a. 3a minus a would be 2a, and cos 2a upon sin 2a would be cot 2a. That's how you are proving the 12th question. And with that, let's begin with the 13th one. Follow this method every time you have the terms only and only in cos on the left hand side, and the terms in cos also should be in a GP. That is 7 into 2 will be 14, into 2 will be 28, and into 2 will be 56. only if these are cos terms and the angles are in a GP, of course with a common ratio as 2, then you will be able to use the method which I am discussing now. All you need to do is multiply the numerator and denominator with sine 7. So 2 sine 7, cos 7, cos 14, cos 28, cos 56. And in the denominator also write a 2 sine 7. Okay. So now 2 sine 7 cos 7, that becomes sine 14. Let's bring yet another 2 in the denominator and a 2 here. So then 2 sine 14 cos 14 becomes equal to sine 28. Bring yet another 2 here. So there will be one more 2 here. Then sine 28 cos 28 into 2, that becomes equal to sine 256. Bring yet another 2 here. I'm sorry, sine 256, no, sine 56. Okay. Bring yet another 2 here and a 2 here. So that would make it 2 sine 56 cos 56, which is basically equal to sine of 112 degrees. So finally we have sine of 112 degrees divided by 2 and a 2 here, make it 16 sine 20 sine 7 degrees. Okay. You have to convert the denominator's sine to cos and let the numerator's sine remain the way it is. So we will prefer to write 112 degrees as sine of 180 minus 68 degrees divided by 16. We can write that sine 7. 7 is basically 90 minus 83. Okay. Sine of 180 minus theta is sine theta. So in the numerator we will simply have sine of 180 minus 68, which is sine 68 degrees, divided by 16 times sine 90 minus theta is cos theta. So that is cos of 83 degrees, which is what you have on your right hand side. And yeah, that's how you're proving the 13th question. Take the 14th one. Sine square minus 160 degrees. Keep in mind, sine of minus theta is minus of sine theta. But if you square on both the sides, sine square of minus theta will be the square of minus sine theta will give you sine square theta only. So sine square of minus 160 is sine square of 160 only. So we have on the left hand side sine square 160 degrees divided by sine square 70 degrees. I think we should write 160 as 90 degrees plus 70 degrees. That will help us to simplify things in a better way. Plus sine 180 minus theta, the thing that you have in the numerator. Sine 180 minus theta. Sine 180 minus theta is sine theta. That's because 180 is an even multiple. So sine will remain sine. And 180 minus theta, you are reaching in the second quadrant, where this entire angle is going to be positive. So it would be sine theta upon sine theta. These two terms get cancelled, giving you a 1 here. And finally we have sine 90 plus theta, that would be cos theta, and square of it would be cos square theta. So in the numerator you have cos square 70 upon sine square 70, but that is equal to cot square 70. Plus 1. It's better to write cot square 70 in terms of tan, because on the right what we want is 20 degrees. So we will convert that cot 70 degrees. We will write it as cot of 70 is being written as 90 minus 20. We have the square of it plus 1. Cot of 90 minus 20, that would be equal to tan 20, and the square of it would be tan square 20. So tan square 20 degrees plus 1 is what we have, and that gives us sec square 20 degrees. Yes, and that's what we have on the right hand side. So that is how we are proving the 14th question. Let's move on with the 15th one. Yet another easy question, because all you need to do is start simplifying cos 4x. The right hand side is anyway in terms of cos x and cos 2x only. So to simplify cos 4x, we write it as 2 times cos square 2x minus 1 plus 1 upon 2 cos x plus 1. And if we expand the bracket here, this would become 4 cos square 2x minus 2 plus 1. Minus 2 plus 1 becomes minus 1. And finally in the numerator you again have a square minus b square. So we can write it as a plus b into a minus b. So the numerator would be 2 cos 2x minus or plus 1 into 2 cos 2x minus 1 upon 2 cos x plus 1, and the term that we should simplify now. Okay, 2 cos 2x minus 1. This term was anyway needed, so we just need to start simplifying this term. Here also we can put cos 2x as 2 cos square x minus 1, and that should help us simplify the entire expression further. So we have 2 times this term being written as 2 cos square x minus 1 into we have 2 cos 2x minus 1, the whole thing divided by 2 cos x plus 1. Now if we expand this bracket, this would be 2 times cos square 2 times 2 cos square x, that is 4 cos square x, minus 2 and plus 1. That minus 2 and plus 1 makes it minus 1. 4 cos square x minus 1, that's going to become 2 cos x plus 1 into 2 cos x minus 1. It's basically the formula of a square minus b square is a plus b into a minus b. 2 cos x plus 1 gets cancelled up and down, and all you are left with is the numerator, that is 2 cos x minus 1 into 2 cos 2x minus 1, which is precisely what you have on the right hand side. And that's how we are proving our 15th question. Let's go on with the 16th one. The last cos square theta is what we can write as 1 minus sine square theta. So cos square theta will be 1 minus sine square x minus 120 degrees. Cos square a minus sine square b. So we will first write that cos square x plus 1 separately, and then cos square a minus sine square b is basically cos of a plus b into cos of a minus b. So cos of a plus b into cos of a minus x minus 120, that would be minus x plus 120. So now if you see, this would be cos square x plus 1 plus 120 gets cancelled, you are left with cos 2x into x minus x would be 0, and 120 plus 120 would be cos 240. But cos 240 is like 180 plus 60. Cos of 180 plus theta, 180 is an even multiple, so the value for this will be equal to cos 60. But this angle lies in the third quadrant where cos theta is negative, so this will have a minus sign here. So the value for that entire expression would be minus of cos 60, and minus of cos 60. Cos 60 is half. So this gets multiplied with a minus half. And finally we have cos square x plus 1 minus half into cos 2x. So here we can write cos 2x as 2 cos square x minus 1, and when you expand the bracket with that half term, the first term will be minus cos square x, the last term will be minus half into minus 1, which is plus half. So the term in cos square x gets cancelled, and 1 plus half gives you 3 by 2, which is what you have on the right hand side. That's how we are proving our 16th question. Going ahead with the 17th one. Convert everything to sine and cos. That's the best way to go about it. So we have 2 upon sine 2x plus cosec x would be 1 upon sine x. Sine 2x is 2 sine x into cos x. Cancel off the 2. Pull out a sine x common, so we have 1 upon sine x. And in the bracket it is 1 upon cos x plus 1. We can club the two terms in the bracket. That gives us 1 plus cos x upon cos x. And 1 plus cos x is basically 2 cos square x by 2. In the denominator also we can write sin x as 2 sin x by 2 cos x by 2. So let that cos x remain the way it is. And sin x is what we are writing as 2 sin x by 2 cos x by 2. Okay. So let's take this 2 which gets cancelled. 1 cos x by 2 gets cancelled in the numerator and denominator. So we are left with cos x by 2 upon sin x by 2, which is equal to cot x by 2. That's the second term. And the first term is 1 upon cos theta, which is equal to sec theta. In this case, sec x. And yeah, that's how we are having our right hand side. And that's how we are proving our 17th question. Okay. The second last question in this video. I think there is a typing error in this particular question from the textbook, because when you are putting x equal to 0, by putting x equal to 0, we are getting a 1 on the right hand side. And when you put x equal to 0 here, this will be 1. This will be cos pi by 3, which is equal to half. So 4 into 1 into half, that would be 2. Plus cos square, even if this was x or even if pi, whatever you call it, if this was equal to 0, if this was x, I can put it as 0, and that would be cos square 2 pi by 3, that is cos square 120. Even if I consider it as pi, pi minus 2 pi by 3 will be pi by 3, that is cos square 60, and this will be equal to 1 upon 4. So the left hand side becomes 2 plus 1 upon 4, which is 9 upon 4, and that is not equal to the right hand side, which is equal to 1. So there is some kind of a typing error in this question from the side of textbook. So this is a question I am not solving in this video, and just bringing out that error in front of you. And with that, we go ahead with the last, that is the 19th question in this video. On the left hand side, you have sin x. For all those who don't get this formula, just check out this simplification. Sin 2x is basically 2 sin x into cos x, right? Let's write a cos x in the denominator here and into cos x here. So now this becomes 2 times tan x. This is cos square x, which can be written in the denominator as sec square x, but that sec square x will be 1 plus tan square x. Okay? So sin 2x can be written as 2 tan x upon 1 plus tan square x. Keep in mind the angle here is 2x and the angle here is x. So while using this formula, the angle is going to become half of whatever it is inside the sin term. Okay? Here we have sin x, so we can use the half angle formula. Write that sin x as 2 tan x by 2 upon 1 plus tan square x by 2. And then we have into tan x by 2, which makes the numerator 2 tan square x by 2. Plus 2 times we have cos x. And there's a similar formula for cos x as well. So what we can do is, we know the formula for cos 2 theta. That is cos square theta minus sin square theta. We can think of it as a 1 in the denominator, and we can write it as cos square theta plus sin square theta. If you divide the numerator and denominator with cos square theta, the first term will be 1 minus the second term would be sin square theta upon cos square theta, which is tan square theta, and the denominator similarly will become 1 plus tan square theta. And that's the formula for cos 2 theta. Check carefully how the angle from here, which was 2 theta, becomes equal to theta on the right. So while applying this formula, whatever angle you have becomes half of whatever the original value is. So 2 cos x, I can write it as 2 times 1 minus tan square x by 2 upon 1 plus tan square x by 2. Now think over it. The denominators 1 plus tan square x by 2 are same for both the terms. So you can simply club the numerators. In the numerator you have 2 tan square x by 2 plus 2 minus 2 tan square x by 2. So 2 tan square x by 2 gets cancelled and we are left with 2 upon 1 plus tan square x by 2. We can definitely simplify this a little beyond, because we can write this as sec square x by 2, which goes in the numerator and becomes cos square x by 2. But we don't have to do it because this is precisely where we have our right hand side. Okay, that's how we are proving the 19th question. And yeah, this is where I am done with whatever I wanted to cover in this video. I hope whatever discussions we have had in this video have been somewhere helpful to you in your preparations. Thank you for watching.